Welcome back, everyone, to Chem 102. My name is Professor El Hawari, and today we will be going over experiment number 8, precipitation chemical reactions and their use in the qualitative analysis of water. So, the first thing you want to do is you want to make a copy of our lab report template. You're going to find this in the course documents folder. Again, you can download the document and edit it, and then you can upload it as a Word doc or a PDF, or you can make a direct copy and you can write your responses and submit it as is. So, the first thing you want to do when you open up your document is you want to put your name on it and you want to put the date in which you complete experiment number 8. And the next part of the lab report, it says in the box below, write one sentence that clearly describes the goal, what you hope to accomplish, and the method used to complete this experiment. So the objective we want you to write is that for this experiment, our objective is to observe and analyze precipitation chemical reactions and apply them to the qualitative analysis of water by identifying the presence of specific ions through the formation of insoluble compounds. Again, the objective is to observe and analyze precipitation chemical reactions and apply them to the qualitative analysis of water by identifying the presence of specific ions through the formation of insoluble compounds. Pause the video and write your objective, and we are going to go to the next section. So, the next section, as always, we are going to list the equipments and their functions that we will be using for this experiment. And the first equipment we'll be using is the beaker. And the function of the beaker, it is a common lab container used to hold, mix, and heat liquids during experiments. We also have the test tubes, and they contain small quantities of reactants for observation of reactions. Today, we will be putting liquids in test tubes and seeing whether or not we are going to get a solid precipitate. And we are going to do so by using a stirring rod. The stirring rod mixes reactants evenly to ensure consistent reaction. Also, we'll be using the disposable pipette, which is going to add precise amounts of liquids to reactants. And we will be using a balance or scale. And the balancing scale is to measure the mass of reactants accurately before the experiment begins. Safety goggles. The safety goggles are used to protect the eyes from splashes or reactions. So make sure you write all these equipments and functions. You can pause the video to make sure you have all these safety equipments and their function listed on your lab report. Let's talk about the theory behind today's lab. Again, this theory, make sure to mention it in the final paragraph for today's lab. We have chemical properties, which is used to describe how particles of substances interact with each other to result in change in composition. So we talked about this last week and we also mentioned it in our lecture. So chemical property will give rise to chemical change, and we represent this with a chemical formula. You need to see a change in the chemical formula, and this is observed throughout the chemical reaction. Now, chemical reaction or chemical change is a chemical substance which is converted into one or more different substances. Now, this happens by virtue of the rearranging, removing, replacing, or addition of atoms. And again, as a few definitions, atoms are the smallest individual particles of an element, and the newly formed substances will always have different physical chemical properties than the starting substance. As an example, around us we have hydrogen atoms, and we also have hydrogen molecules and oxygen molecules. These will be our reactants because they are on the left side of the arrow. When these two reactants combine chemically, we are going to form water. So water, notice it's after the arrow, it's our product. And this, the water will have completely different chemical and physical properties from the oxygen and the hydrogen reactants. Some examples of chemical properties: flammability, which is the how likely the substance is going to burn; reacts with combustion; oxidation, tarnishing, rusting from oxygen; decomposition. And the thing we're going to focus on today is forming a precipitate. The definition of a precipitate, which we will cover, is when you mix two liquids and you have a solid as a byproduct. And again, a chemical property, inertness. So the lack of reactivity is also, as we mentioned, a chemical property. And precipitate will look something like this. We're mixing two liquids, and as a result, you're going to get a solid. Now let's talk about the chemical equation. Your chemical equation, as we mentioned, anything that comes before the arrow is called the reactant. Anything that comes after the arrow is called the product. And the reactants on the products are separated by an arrow, which is is like our equal sign in chemistry, just like in math class. So the arrow is our equal sign. It symbolizes how substances are changed by a chemical reaction. Now, when there is more than one reactant, we separate them by a plus sign. So we say MgNO3 plus NaOH. Every reactant and product is going to get a physical state. When you see a Q, that means it's aqueous, which means it's dissolved in water. So that means the NaOH is dissolved in water, the MgNO3 too is dissolved in water, the NaNO3 is also dissolved in water. Now for MgOH2, you're going to see S. S means it's a solid. L would mean it's a liquid, and G would mean it's a gas. By the way, this reaction that we're looking at is similar to the reaction we're seeing today, which shows us that when you mix two aqueous, you're going to form a solid. This is a precipitation reaction when you mix two liquids and you get a solid. Another thing is that chemical equation must be balanced because the atoms are not created or destroyed in a chemical reaction. They have to stay the same. So the number of atoms that we start with on the left side of the equation on the reactant side has to add up to the number of atoms that are formed on the product side. So another quick review. We did this last week. Let's review this because this will also come in handy for today's lab. How many reactants there are? We have two reactants, the Cu and the HNO3. Uh, how many products there are? We have three products. We got the CuNO3 2. We have the NO, which is nitrogen monoxide, and we have H2O. Three, are there any gases in the equation? And the answer is yes, the nitrogen monoxide, the NO gas right here. What is the physical state of copper in the reaction? The physical state is solid. What is the coefficient of nitrogen monoxide? The coefficient, as you remember, is the number that comes up front before the equation or before the chemical formula. So the coefficient would be 2. And as a review, that 2 is a coefficient, 3, 8, 3, and 4. All these numbers are coefficients. And the little numbers, for example, HNO3, this 3 here is called a subscript, which is a number written at the bottom of each element that tells us how many of this atom we have in the compound. Number 6, how many hydrogen atoms are in the reactant? So let's go to the H. So HNO3H, what's the subscript? Nothing is written, so we assume it to be, very good, 1. And what we do, we multiply the coefficient by the subscript. So 8 times 1 is 8. So we have 8 hydrogen atoms on the left. And if we look on the product side, hydrogen, the 2 under H, this is the subscript, and the coefficient is 4. 2 times 4 is also 8. So this shows us that we have 8 hydrogens on the left and also we have 8 hydrogens on the right. Now let's talk about the common evidence of a chemical reaction. If you see a color change that is after you did something, for example, if you mix two chemicals and you have a completely new color, that means it's evidence that we have a chemical reaction. If you have a formation of a gas, this is evidence of a chemical reaction. And how are you know you're going to have a gas? You see bubbling or foaming if the reaction takes place in a liquid. Formation of a precipitate, that's what we're going to focus on today. That's the goal of today's experiment. A precipitate is an insoluble solid. Insoluble means this solid is not going to dissolve in water. When you have an insoluble solid that is forming in a liquid, it is a chemical reaction. Again, it is not the same as freezing. And freezing, by the way, is a physical change by which a liquid becomes a solid at a certain temperature. So it's not like we're taking the substance and freezing it. We're actually getting an entire new substance in the solid phase. Two more reactions. This is we also mentioned this last week. Exothermic reaction is a reaction that releases a ton of heat. Endothermic reaction, on the other hand, is a chemical reaction that absorbs heat. Exothermic reaction are going to be very hot, so they're going to feel warm to the touch. Endothermic reactions are going to be very cold, so it's going to be cold to the touch. Note, many reactions are going to take place without any visible changes. Other methods are required to confirm the reaction has occurred. Another thing you want to know is that when substances dissolve, this means it's a physical change, so you may observe an absorption or release of heat. These are physical changes. The word mix implies that it's physical. A chemical reaction does not take place when you dissolve or mix or when there's a change of state. For example, if you go from solid to liquid, this is melting. Melting is considered physical because you still have the same substance. So phase changes are physical changes. Single replacement reaction is a reaction that occurs when you swap places. For example, we have A plus BC. When the A switches with B, we are going to get a single replacement reaction. For example, the Cu in this is kicking out the Ag, the Na is kicking out the hydrogen, which is called a single replacement reaction. A double replacement reaction is when both partners switch. For example, AgNO3KBr, the Ag is going to pair up with the Br, the K will pair up with the NO3, giving you a double replacement reaction because both reactants are switching partners, giving you two new products. And if we look here, we have AgNO3AQ, KBrAQ. Two AQs are mixing together, and as a result, we're going to get AgBr solid. This is our precipitation reaction. AgBr, it's a solid because it's insoluble in water, which means that it is not going to dissolve in water. Qualitative analysis now. This lab is important because we use it to analyze different or track the reaction, track whether the reaction has gone to completion based on analyzing the ions in the sample. So this refers to an experimental method that is used to identify the substances that are present in a sample of matter. This does not indicate, however, the quantity of material present. This is just a qualitative analysis. This also can refer to the analysis that can be conducted by adding chemicals to an unknown sample and observing what changes occur, if any. Certain changes are known to correspond to the presence of certain substances in a sample. So, very important, the lead ions, and this has been a problem, especially in a lot of New York City high schools. The water is contaminated with lead. So, how do we know if the water safe to drink, because as we know, lead is very toxic. So we perform a qualitative analysis, and sometimes we also perform quantitative analysis. So as we know, lead ions, when they dissolve in water, they are harmful to human health. But when we add some chloride ions, it's going to form a white precipitate. So if you see a white precipitate when you add chloride ions to water, it's a bad thing. That means we have lead in the water, which means this water needs to be cleaned as soon as possible. So Pb2 plus AQ, it dissolves in water. Cl minus AQ dissolves in water. When both come in contact with each other, you get PbCl2 solid, which is a white precipitate, which shows that it's a bad thing. On the other hand, copper 2 ions plus Cl minus ions, when they mix together, you have no reaction. So there is no precipitate. So precipitate depends on the nature of the two opposite charges that come in contact with one another. So therefore, if a source of Cl minus, such as NaCl, is added to a solution and you see a white precipitate observed, the solution may have Pb2 plus. We're not sure. We need to do more tests, but there's a big chance it's Pb2 plus. So today's experiment, we're going to need a test tube rack, scopula, disposable pipette, beaker, and stirring rod, and we will be testing 4 reactions. So make sure when you go to the lab report, you are filling the data for 4 separate reactions. All the reactions we are going to perform are going to take place in a test tube. And when the test tubes are not in use, we're going to put them back in the test tube rack. You're going to write down all the observation for every reactant. That's the first step. We are going to obtain 4 clean test tubes and label them 1, 2, 3, 4. We're going to pour a few milliliters of each solution in a separate clean 50 milliliter beaker. Now in test tube 1, we're going to use 2 clean disposable pipettes to add a few milliliters of both sodium chloride NaCl solution and silver nitrate AgNO3 from their respective beaker, and we're going to notice what is going to happen. In test tube 2, we're going to add barium chloride with sodium sulfate. For test tube 3, we're going to add lead 2 nitrate with potassium chromate. And for the fourth reaction, we're going to be adding magnesium hydroxide, a few grams of it. So it's actually a solid, and we're going to add it to hydrochloric acid, and we're going to note what is going to happen. So let's start. So this is the setup. As you can see, we got 4 test tubes, a lot of disposable pipettes, and let's start with experiment number 1. Experiment number 1, again, we will be adding sodium chloride. So in your data table, make sure you write what is the initial appearance of sodium chloride and silver nitrate. As you can see, sodium chloride is a clear liquid. It doesn't have any color. It looks like water. So write that in the first box. And we're going to show you silver nitrate. So sodium chloride is 1 molar, which means it's not molar means that's the concentration. We're going to talk about that in a future lesson, future video. So as you can see here, we get the silver nitrate. And notice the color of the bottle where silver nitrate is in. It's in a dark bottle. And notice we pour it. Silver nitrate is a clear and it's a colorless liquid. Just if you look at it, you might think it's water, but it is not water. All right, so you see a colorless liquid, silver nitrate, and it's in a dark bottle. Sodium chloride, it's also a colorless liquid, but it's in a clear bottle. We're going to pour a little bit of sodium chloride, which is NaCl. What is the state of matter? Notice it's a liquid. So we say AQ because we know that it has NaCl, it has salt. So this is salt water. You're going to take a little bit of salt water, NaCl, using the disposable pipette. Notice what happens now when we add it to the silver nitrate. Both are clear, colorless liquids. We're going to go now to test tube 1. So the reaction will be inside test tube 1, all right? So the NaCl is added. Now let's take the AgNO3s, the silver nitrate. So we can actually make a prediction. This is called the chemical equation right here. You're seeing it. So we can make a prediction. But let's see what is going to happen first, and then let's go back to the equation. Let's add a few drops. Again, it's a clear colorless liquid. Make sure you're writing that. Okay, watch. Make sure you're watching and seeing what's going to happen. We're going to add a few drops. We're going to lower the disposable pipette. All right, watch it. The drop is going to drop. Look at that. Look at that. As soon as we mix it, you see it's getting cloudy. And now that this cloud is the new substance called AgCl, silver chloride. And believe it or not, that white cloudy substance is a solid. You can filter it and you can hold it in your hands. It's actually a white solid. And if you look, we're gonna get the stirring rod. We're gonna agitate it a little bit to make. You can see it. You can see it's a solid. You can see the solid right here. It's interdispersed. Look at that. It's a solid. So silver chloride is a solid. So this is a precipitation. Is this physical or chemical? That's a chemical reaction. So we're mixing two colorless liquids, and as a result we're getting a solid silver chloride. Look at that. The solid is precipitating to the bottom because it's more dense than water. So reaction number one is a chemical change showing us a precipitation reaction. Two liquids becoming a solid. Very good. All right, right. Make sure to write down all the observations of all the reactants and fill your data table. The next reaction is between barium chloride and sodium sulfate. Again, wait, let's go back. Yes. So let's see the reaction. Make sure to write down the observation. Barium chloride is a clear colorless liquid. We're using 1% of barium chloride. We're going to pour it in a beaker. This equipment is called a beaker. We're going to close. Yes. 1% BeCl2 aqueous. Aqueous means it's dissolved in water. Look at that. And then we have the sodium sulfate, Ne2SO4. Again, it's a clear, colorless liquid. Pour a little bit. Next, what we're going to do is we are going to mix both of them. But before clear, colorless liquid, as you can see, we're going to now use the transfer pipette. Take some of the barium chloride. And notice we put it in a beaker so we don't contaminate the original bottle. Take some barium chloride, put it in a test tube. Very nice. And now let's see what's going to happen when we add the sodium sulfate. Another clean pipette. Take some of the sodium sulfate, add it to the test tube, and watch what happens. Let's see. Let's see. We're adding it. Watch the bottom of the test tube. And as you can see, it's getting cloudy. It's not as cloudy as the first one, but it's getting cloudy. And this is actually another solid. We're going to agitate it and we're going to let it settle to the bottom. It's actually barium sulfate, which is a white substance. It's also a white solid. So this is the second reaction. As you can see, it's not as pronounced as the first one, but as you can see, this is a chemical change. So the second reaction, generating barium sulfate, is also a chemical change. Write down the colors that you're seeing and write down your observations, and we're gonna go on to reaction number 3. Reaction number three, now we have different colors. It's going to be between lead nitrate, which is a clear colorless liquid on the left, and we're going to have potassium chromate, which has this yellowish color tinge to it. So let's start with the experiment. We already poured it in our beakers. So now we have we're lowering the potassium chromate. Oh, look at see what happened. Look at that piece of solid. This is I would say the best experiment so far. Look at that. Very nice. You can see now this is not this is not a gas. This is not a liquid. This is actually a solid that we can filter. And this is the lead 2 chromate. Yes, as you can see, we're gonna agitate it, and it's a beautiful and it's a beautiful yellow precipitate. Look at that; it's a beautiful yellow precipitate that will settle to the bottom. So initially, potassium chromate is yellow. It's aqueous, and lead nitrate is a clear colorless liquid, and we mix them, and as you can see, when we mix them, we get this beautiful, if you can just see it one more time, look at that, beautiful. As soon as the drop hits the liquid, beautiful color. Look at that, it's a beautiful, and you can see it's a solid and it's going all over the place. Beautiful color. So this is reaction number three. Write down your answers in your lab report, and we will be going to our final experiment for today, reaction number four. All right. Reaction number four, we are going to take some magnesium hydroxide, but in this case, it's a solid. So notice, because we're starting off with a solid, we're going to put S in our chemical equation. And next, we're going to have 1 molar hydrochloric acid, which is the concentration of the acid we'll be using. And let's see what we are going to make. So we're going to take some solid magnesium hydroxide. And again, look at the color of the bottle. The bottle is dark. Some substances need to be stored in a dark environment because they don't like to interact with light. All right, we're gonna magnesium hydroxide. All right, see if there's a continuation to the video. There is. So we have a solid magnesium hydroxide at the bottom. Again, the state of matter is solid. And now we are going to add the hydrochloric acid. Pipette, take some acid, and notice what happens in the reaction. So the acid now is interacting with the magnesium hydroxide, and notice. Now this is an interesting reaction because you might think that there is no reaction. So in your observation, you're gonna say the magnesium hydroxide is a solid. The hydrochloric acid again is a clear colorless liquid. And when we mix them together, if you see, uh, the magnesium hydroxide is gone. So you might be thinking, oh, this is dissolving. This is a physical change. And this is why we need to look at the balanced equation. If we look at the balanced equation, when you put magnesium hydroxide with hydrochloric acid, this is what we call an acid base reaction. And in an acid base reaction, this is a special double replacement reaction. The OH is going to combine with the H, and we're going to get water liquid, and the Mg is going to combine with Cl, giving you MgCl2. Now everything is aqueous, it's dissolved in water. Whenever you mix a solid and something that's aqueous and you get pure liquid, this is still considered a chemical reaction. So you might be wondering, hey, we did not see any bubbles, we did not see any color change. but this is still a chemical reaction. And another way we can know that this is a chemical reaction, if we boil off the water, we are going to get we're not going to get back our magnesium hydroxide, which is also going to prove that a chemical reaction has occurred. And also, we have magnesium chloride aqueous solution. So, this is a special chemical equation that does not produce any noticeable colors. And we can also use pH paper to prove that this was a chemical reaction. All right, so this is a special case where we have an acid base reaction. All right, so again, here are all the observations, the before and after. As we see, I would say the best reaction out of all of them is reaction number three, where we got that beautiful yellow precipitate. The last reaction we say had no precipitate because we don't see any solid, everything is liquid, but all four reactions are considered chemical reactions. Very important. You after you complete all your data table, so you have four data tables to complete. In one or more paragraphs, you want to summarize the results of this experiment. You want to write in full sentences. Avoid using bullet points or sentence fragments. Describe any trends or patterns you observed. Make an effort to support your statement by referring to the theory in the pre-lab discussion. For instance, do all the reactions produce completely unique observations? Support your statement with examples from the data. As we saw, last reaction did not. So, as an announcement, you are expected to complete the following tasks for each experiment by the due date. Watch the assigned video, which you did very good. You're going to complete the quiz based on the experimental video, and also don't forget to submit your lab report using the given template based on the video. Thank you and see you soon.